Hello everyone. In this video, we will have a bird eye view of statics, which is considered as the keystone of strength of materials. I will try to go step by step so that the concept of statics is realized by all, and which is very important in order to solve the problems pertaining to strength of materials. So statics is the branch of mechanics which deals with the forces in the absence of motion. So strength of materials, which is also abbreviated as SOM, is also known as mechanics of materials or mechanics of deformable bodies. So a deformable body is a body which undergoes deformation, means which undergoes change in shape or change in the size upon the application of force. So the main purpose of strength of material is to investigate the internal resisting forces of the body. Means we have to know about the forces which are developed inside the body due to the externally applied load. So in simple terms, you can say that strength of material deals with internal forces, deformation and external loads. The first and foremost assumption to solve the problems in strength of material is the condition of equilibrium. Means here body is assumed to be in this state of equilibrium. After that, we have to prepare a sketch of the body which shows all the forces which are applied on the body, including the reactive forces, external loads, as well as the body weight. And this sketch is known as the free body diagram and is also abbreviated as FBD. After that, we have to use the method of sections. In this method, we have to pass an imaginary plane which cuts through the body at the point of interest. Means we have to take a plane and such that that plane will cut the body into two halves or more than two halves at the point of interest, means at the point where you want to find out the internal resisting forces. After that, we have to apply the equations of static equilibrium so that a relation is obtained between the external forces as well as the internal resisting forces. So here we know the external forces, but internal resisting forces are unknown to us. So in order to solve this problem, we have to express the internal resisting forces in terms of external loads. So this is the trick here, which will get clear from the next slides. So for equilibrium, what we will have to do, there should be balance of forces and balance of moments. So why we need to do balance of forces? Because we want to prevent the body from translating or having an accelerated motion, and that accelerated motion can be along a straight path or a curved path, and there should be a balance of moments. Moments are trying to rotate the body, so we want to balance the moments so that the body is not able to rotate. So here balance of forces is denoted by sum of forces which is equal to 0 and sum of moments also equal to 0. So here MO means moment at any point O. So if we are considering a three-dimensional body, means we have x, y and z coordinate axis. So in that case, we have to put the forces equal to 0, means sum of all the forces should be equal to 0 along the respective directions, along the x direction, y direction and z direction. Same procedure will be followed for the moments. But in engineering, most of the cases we are dealing with the coplanar forces or coplanar loading, means load is acting only in the xy plane. So in that case, what we will do, we'll have to equate the sum of forces equal to 0 along the x and along the y direction. And we have to equate the moment about the particular point which is under investigation equal to 0. The known and unknown forces can be visualized with the help of the free body diagram. So free body diagram is the important step which is to be done before moving or before applying the equations of the equilibrium. So suppose this is the body. So here this can be considered as a free body diagram of a body which is subjected to four forces F1, F2, F3 and F4, such that F1 and F2 are trying to pull the body in the downward direction and F3 and F4 are trying to pull the body in the upward direction. Suppose we have to find the internal resisting forces somewhere between the midpoint of the body. So what we will do, firstly we have assumed that body is in equilibrium, means these forces are maintaining the body is in a equilibrium state. So after that we will have to make a free body diagram, which is the free body diagram here. Now we have to apply method of sections, means we'll pass an imaginary plane which cuts through the body at our point of interest. And we will consider one part of the body. Here I am considering the bottom part. You can also consider the topmost part. So here the bottom part is subjected to F1 and F2 forces. So if this bottom part is subjected to F1 and F2 forces, there are no forces in the top directions. So these forces will try to pull the body in the downward direction. But we have assumed that body must be in equilibrium. So there should be some forces on the top side of the body. So these forces can also be considered as the forces which are developed in effect of the topmost part which has been removed, or this can be assumed to be developed so that it is maintaining the body in the equilibrium and it is opposing the forces F1 and F2, and these arrows represent the internal resisting forces. They can be represented either by 1 arrow or 20 arrows. So we do not know the directions. So here you can see some are pointing downwards, some are pointing upwards. So now as there are forces, these internal resisting forces are in different directions. So what we have considered, so I'm considering the net resultant force, which is represented by Fr, and net resultant moment, which is represented by Mr, about the point O. So this point can be considered as the point O. So now how we have obtained this Fr? So you can see this body. So along this cross-sectional area, there will be forces which are perpendicular to this area and which are parallel to this area. And so normal force is denoted by N, parallel force is denoted by V. So by using simple vector addition, we can have the resultant force Fr. So in this way, I have obtained the resultant force which represents the forces perpendicular or parallel to the cross-sectional area. So here forces either can be parallel or perpendicular to the area. Now what about the moment? So moment, there is a bending moment which is denoted by M, and there is a twisting moment which is denoted by T. So now if we have to find the resultant of the bending and twisting moment, that can be represented by MRO. So I will make this thing clear that what is a bending and what is a twisting moment. So why bending moment is taken in this direction, whereas twisting moment is taken in the perpendicular direction. So resultant of this bending and twisting moment has been taken, which is represented by MRO. So here These letters NVTM represents the normal force, shear force, torsional moment or torque, or bending moment. So the bending moment occurs along the axis, or you can say that bending moment occurs about the axis which is parallel to the cross-sectional area. So suppose this is our coordinate axis system. So the torque will occur or will occur about the axis which is perpendicular to the cross-sectional area, and bending moment will occur along the axis which is parallel to this cross-sectional area. So we all know sagging and hogging in a beam. So if a beam is bending in the downward direction, you can see how my cursor is moving. So this is sagging, so it is bending in the downward direction, or hogging if it is bending in the upward direction. So this will bend about this axis. So this is known as the sagging and hogging, and it is occurring about the axis which is parallel to this cross-sectional area. Now suppose I am holding this beam from the left hand side and the right hand side through my hand, and suppose it is flexible and I am pulling the beam towards my side such that the center portion is not moving. So the beam is bending about this axis. And suppose if I am applying the force or such that the beam is bending in the backward direction, so that will occur about this axis. So this is known as the bending moment. So this is occurring about the axis parallel to the cross-sectional area. So torsion or torque occurs about the axis perpendicular to the cross-sectional area. This can be remembered by a simple trick. We know that the sign of perpendicular is the inverse T. So, and here torque is also represented by T. So inverse T and T can be remembered as the point such that the torque always occurs to the perpendicular direction of the cross-sectional area. Now, as I was I was saying that bodies are subjected to coplanar forces. So let us summarize what we have studied. So here, this is the body which is subjected to these four forces. Now it is in equilibrium. I am passing an imaginary plane such that this imaginary plane cuts the body in two halves. So these are the two forces. So now these two forces will try to pull the body, but this body should be in equilibrium. So there will be a normal force, a shear force, and bending moment. So in a coplanar body, there will be normal force, shear force, and bending moment. There will not be any twisting moment in the coplanar forces. This can be remembered. And to calculate the normal forces, force along x direction is put equal to 0. In order to calculate the shear forces, force along the y direction is put equal to 0. So here this x and y directions are taken as drawn here. Means x direction points toward the normal force, y direction points toward the shear force. And bending moment is taken about the z-axis, which is out of the plane of the paper, and that is put equal to 0 in order to eliminate the moments caused by the shear force and the normal force. So let's quickly summarize this. So normal force is the force which acts perpendicular to the area such that its effect is to push or pull the two segments of the body. So either it will pull the body or push the body. And shear force, this lies in the plane of the area such that its effect is to slide the body one over the another. So here you can see, if you place this right portion of the body here, so you can see shear force is pointing upward direction. So this right hand left hand side portion of this body will slide over one another, whereas this force, normal force, will either pull the body or push the body if it is applied in the opposite direction. Torsional moment or torque it tends to twist one segment of the body with respect to the other about an axis perpendicular to the area. So perpendicular can be remembered with the sign of the perpendicular, which is inverse T. So bending moment is the external loads that tend to bend the body about an axis lying within the plane of the area. So I hope this method of statics, which is the foundation of the problem solving techniques in the strength of material, is clear to all. So thank you for your time. Keep learning and stay tuned for the upcoming videos.